So question number 4 in activity 1.3 displays a copy of the table from question 1, which gives the value of a Honda Accord after n number of years of ownership. We're going to use this table and the data to answer some questions. Question 4a asks for a title. Again, remember what's in the data table, right? This data table reflects the value of a car or the value of a Honda Accord for n number of years. So we should have a title that appropriately reflects this information. So my title is Value of Honda Accord Over Time. Perhaps you came up with a different title or a better title. That's fine. Next, we're asked for word and variable labels on each axis. So it says write the appropriate variable label on each axis, write an appropriate word label on each axis. So going back to my table, we remember the input was the age of the car, and the output was the value of the car. So we place the input information along the horizontal axis. My word label was age of car in years, and my letter for that would be the letter N, or that's my variable. And the word label for my for my vertical axis is value of car in dollars, and my variable label would be this V. Next, question 3 asks, what is the scale on the horizontal axis? That is, how many units does each tick mark represent? So it looks like we're counting by increments of a half a year. So the first tick mark would be 1/2 of a year, the second tick mark would be a year, year and a half, 2, 2.5, 3, and so forth. So I'll fill in a half a year. We are then asked for the scale on the vertical axis. It looks like we're counting by increments of 2,000. So the first tick mark would be 2,000, 4,000, 6,000, 8,000, and so on. So I'll fill in $2,000 for question 3b. Question 3c says label every other tick mark on the vertical axis. So I've gone ahead and added 12,000, 16,000, and 20,000 to my graph. Question 4b says to write the coordinates of point A and point E on our graph. So here's point A and point E, and we're going to add the coordinates. So you can see I've added the coordinates 0, 20,025, and 5, 13,100. Now, if you're not sure where the 13,100 comes from, well, just remember, E looks like it lines up over 5 years. And if I go back to my table, at 5 years, the value of the Honda is 13,100. And when I look at point A, or the coordinates for point A, well, A is happening at 0 years, or the initial value of the Honda. So again, if I look back to my table, when the car is brand new or has an age of 0, the value is 20,025. And that's what you see on my graph. Question C, or 3C, says connect all the points, and then ask what pattern do you see? So I've connected all of the points, and it looks like we have a straight line. So I'll fill in a straight line for part C. The book does a nice job of summarizing what we've done in the 2 videos, right? We started with a table of ordered pairs in which the average rate of change is constant. Right? If you remember earlier on, we had the ordered pairs and we were asked to complete the average rate of change, and it looked like we came up with this negative $1,385 each time. We then decided that if the average rate of change is constant, we then have what we call a linear function, and it's a graph which has a non-vertical line. The constant rate of change is called the slope and is denoted by the letter m. And then we're given another definition that says m, or the slope, is the change in y over the change in x, which is the same thing as saying the change in output over the change in input. And then sometimes you'll see it referred to as this y2 minus y1 over x2 minus x1. So if we take a look at question number 5, they ask us, what is the slope of the line graphed in problem 4? Well, here's problem 4, so let's use that notation, y2 minus y1. So this 0 would be my x1, and the 20,025 would be my y1. And on point E, the 5 would represent x2, and the 13,100 would represent y2. So when I perform the algebra, using that formula, y2 minus y1 over x2 minus x1, I end up with the 13,100 minus 20,025 over 5 minus 0, and that cleans up to be negative $1,385 per year. So the slope of the line graphed in problem 4 is that negative $1,385, right? So that represents the steepness of this line, right? The slope, or the average rate of change. Next, we're asked, what is the relationship between the slope of the line and the average rate of the change? Well, they're the same. What is the practical meaning of the slope in this situation? Well, the car depreciates or loses $1,385 each year. That concludes this lesson.